Good evening.
Continuity. Definition of continuity. A function f of x is said to be continuous at a point x is equal to a in its domain if the following three conditions are satisfied. First, f of a exists, that is, the value of f of a is finite. Second, limit x tends to a of f of x exists, that is, the right hand limit is equal to the left hand limit and both are finite. The third, limit x tends to a of f of x is f of a. The function f of x is said to be continuous in the interval I of x1 x2 if the three conditions mentioned above are satisfied for every point in the interval I. Discontinuity. If any of the three conditions for a function to be continuous fails, then the function is said to be discontinuous at that point. On the basis of the failure of which specific condition leads to discontinuity, we can define different types of discontinuities. The first one, jump discontinuity. In this type of discontinuity, the right-hand limit and the left-hand limit for the function at x is equals to a exist, but they are not equal to each other. It can be shown as this graph. Infinite discontinuity. The function diverges at x is equal to a to give a discontinuous nature here. That is to say, f of a is not defined. Since the value of the function at x is equal to a tends to infinity or doesn't approach a particular finite value, the limits of the function as x tends to a are also not defined. This can be shown by the graph here. And point discontinuity. This is a category of discontinuity in which the function has a well-defined two-sided limit at x is equal to a, but either f of a is not defined or f of a is not equal to its limit. This discrepancy can be shown as limit x tends to a of f of x is not equal to f of a. This type of discontinuity is also known as removable discontinuity, since it can be easily eliminated by redefining the function in such a way that f of a is equal to limit of x tends to a of f of x. This can be shown by the graph here.
That's it.
Yes, sir.
It was good, but in the beginning, you should have told that the meaning of continuity. A function is said to be continuous if graph of the function is continuous, that is without any break or gap. And then it is not possible and advisable also to draw the graphs in all the cases. So we use method of calculus to discuss the continuity of a function. So today's topic is continuity. Suppose the function f is defined as y equal to fx and is given as y equal to f of x equal to x. We know that the graph of y equal to x is a straight line, right? So this is graph of the function y equal to f of x equal to x. It can be seen that this graph is continuous, that is without any break or gap. It has no breaks or jumps. We say that the function f is continuous. If a graph has break or jump, then we say that function f is discontinuous. Now it is not possible and advisable also to draw the graph in each and every case. So we use method of calculus to define or to discuss continuity of a function. Initially, we are going to discuss continuity of a function at a point, then in the interval, and then over the complete domain. Can you tell me if f of x is x square minus 4 upon x minus 2, what is f of 0 and what is f of 2? Type your answer in chat box. Suppose this is f of x. Can you tell me what is f of 0 and what is f of 2? Type your answer in chat box. Most of the students have given correct answer for f of 0. Yes, f of 0 is 2. But most of the students have said that f of 2 is 4. That is wrong. Why? Because f of 2 is not defined. Because if you replace x by 2, 2 square is 4, 4 minus 4, 0, upon 2 minus 2, 0, 0 by 0. So clearly f of 2 is not defined, right? Let us try to draw the graph of this. Clearly, I have to say that x belongs to R, but x is not defined at 2. So x is not equal to 2. Now, can I simplify the function? What are the factors of x square minus 4? X minus 2, x plus 2. X minus 2 gets cancelled. So x plus 2. Why can we cancel x minus 2? Because x is not equal to 2. Now let us draw the graph of this function y equal to x plus 2. Now when x equal to 0, what is y? Y equal to 2. Suppose this is 1 and this is 2. So this point lies on the graph. And when y equal to 0, x is minus 2. Okay. So this point also lies on the graph. But note that if I say that, just a minute. Okay. See, this graph is not correct. Why? Because when x is 2, this point is on the graph. But note that for x equal to 2, f of x is not defined. And therefore, we should not show this particular point. Means there is break or gap at this point. Yes. Now this is correct. This is the graph of the function y equal to f of x. Because for x equal to 2, f of x is not defined. This means that the function is not continuous at which point? At x equal to 2. But you will also observe that if you put x equal to 2 here, you get y equal to 4. That is f of x equal to 4. So if we define function in this fashion, that f of x is x square minus 4 upon x minus 2 for x not equal to 2, and f of x equal to 4 for x equal to 2. See, this is called as piecewise function. We have already discussed this. One important thing for calculus, the basic requirement is you should know the topic functions, definition of function, different types of functions, etc. Logarithmic function, trigonometric functions. Now you will notice that for x equal to 2, they have said f of x, that is y equal to 4. So this point lies on the graph, and it can be seen that graph of the function f of x equal to x square minus 4 upon x minus 2, x not equal to 2, and f of x equal to 4 for x equal to 2 is now continuous. That is, there is no break or gap. So function is continuous. As I said, it is not possible and advisable also to draw the graph in each and every case, and therefore we use concept of calculus to define continuity. So what is that definition? See, I have given example because you should understand why concept of limit is used. A function f, listen to me carefully, a function f is said to be continuous at a point x equal to a. A function is said to be continuous at a point x equal to a if, number one, f is defined at x equal to a. That is, f of a exists. Okay, this is the first condition. Second condition, limit extends to a, f of x should exist. And the third condition that limit extends to a, f of x must be equal to f of a. Then and then we say that function is continuous at x equal to a. If at least one of the above conditions, fails, then we say that function is discontinuous at x equal to a. So in this example, we must prove that this 4 is nothing but value of the limit of the function as x tends to 2. Let us see. Limit x tends to 2, f of x. What is f of x? X square minus 4 upon x minus 2. What are the factors? X minus 2, x plus 2, denominator x minus 2. Can I cancel x minus 2? Yes, I can, because x only tends to 2, x is not equal to 2. So I get limit x tends to 2, x plus 2. Take the limit 2 plus 2, that is 4. As f of x is given to be 4 at x equal to 2. Now you may ask me, why 4? See, it is given. They could have given 14 also, or they could have given 3 also. Suppose f of x is 3, then we will say that there is break, there is gap. So the function is not continuous at x equal to 2. But they have defined f of x as 4 at x equal to 2, which happens to be value of the limit. And that is why the function has become continuous. For any other value than 4, function will be discontinuous at that point. I hope this is clear to you. I'll again tell you this definition. A function f is said to be discontinuous at a point x equal to a if, number 1, f of a exists. Number 2, limit x tends to a, f of x exists. Number 3, limit x tends to a, f of x equal to f of a. If at least one of the above conditions fails at x equal to a, then the function f is said to be discontinuous at x equal to a. Now continuity from the right and from the left. Let us consider limit of fx as x tends to a. Now what is the meaning of x tends to a? It means x takes values very close to a and approaches a. But we are not sure whether x approaches a either from left or from right. So the first case, if x takes values less than a, see, I'm not saying positive, negative, it all depends on the value of a. But initially, x takes values less than a and approaches a, then we say that x tends to a from the left, and we denote it using this symbol. How to read this? Limit x tends to a minus. Remember, a minus does not mean minus a. It can be x tends to minus a minus, right? Minus a minus means x approaches minus a from the left of minus a. As simple as that. If as x tends to a from the left, f of x approaches a number L1, then we say that L1 is the left-hand limit of fx as x tends to a minus. And how to write this? We write this as limit x tends to a minus f of x equal to L1. Okay, this is the first part. Now, what about second part? If x takes values greater than a and approaches a, then we say that x tends to a from the right, and we denote it by x tends to a plus. Now, x tends to a plus means x tends to plus a plus. Yes, because by a we mean plus a only. Yes. If as x tends to a from the right, f of x approaches a number L2, then we say that L2 is the right hand limit of the function, and we denote it as limit x tends to a plus fx equal to L2. Clearly, limit of a function exists if and only if L1 is same as L2. So how can we now define continuity? A function f is said to be continuous at a point x equal to a if, number one, f of a exists. This has to. Otherwise, there is no point in discussing continuity at that point. Limit extends to a minus fx and limit extends to a plus fx. Both these limits should exist. Okay. And third important criterion, limit extends to a minus fx equal to f of a. See, definition is not different, but in some cases we have to find left hand and right hand limit separately. So in that case, basically, if we prove that left hand limit is the same as right hand limit, means limit exists. And if that limit is the same as f of a, then function is continuous. Otherwise, function is not continuous, means it is discontinuous. I have already given notes on this particular topic, continuity. So in that, detailed information theory part is given. So what are the examples of continuous functions? You will notice that for most of the functions, the maximum possible domain is set of real numbers. I'm saying most of them, not all. For example, for constant function, identity function, modulus value function, power function, polynomial, sine, cosine, exponential functions. For all these functions, the domain is R. For logarithmic function, it is R plus, because logarithm of 0 and negative number is not defined. Then for a rational function, we have to say that rational function is defined if denominator is not 0. Then you should know domain for tangent, secant, cotangent, cosecant functions, etc. Okay, just a minute. I'll show you. Yes, I'm talking about this. You can go through this part. See examples of continuous functions. I'll upload this on website also. Then properties of continuous functions. If the functions f and g are continuous at a point x equal to c of their common domain, then f plus g, f minus g, f into g, kf, where k is constant, are also continuous. Then this rational function is also continuous. Actually, we should say quotient function, because every function of the type f upon g is not rational. For that, f and g should be polynomials, right? But what is the main requirement here? G of c should not be 0. See, if denominator vanishes, function is not defined. Then third part is important. If f is a function from a to b and g is function from b to c, then the composite of f and g denoted by g of f is defined as g of f function from a to c, such that g of f of x for all x belonging to set A. If function f is continuous at x equal to c and g is continuous at f of c, you have to use common sense. See, function is continuous at x equal to c means f of c is defined. And in that case, g of f of c should also be defined. See, g is continuous at f of c. Then the composite function is also continuous at x equal to c. Actually, the next part is types of discontinuities. Before we discuss that, let us solve few examples on the preliminary part. Exercise 8.1. Examine the continuity of first one, f of x equal to x cube plus 2x square minus x minus 2 at x equal to minus 2. See, logic is simple. We are asked to examine continuity at minus 2, means we have to examine rather, whether the function is defined at minus 2 or not. Yes, it is. See, because what is the type of the given function? It is polynomial function. Polynomial function is continuous on R. R means set of real numbers. Is minus 2 real? Yes. Is fx defined at x equal to minus 2? Yes. So what should be the answer? Function is continuous. It is better if you underline this. Function is continuous at x equal to -2. Right up. Second, f of x is sin x for x less than or equal to pi by 4 equal to cos x for x greater than pi by 4 at x equal to pi by 4. What does this mean? This means you have to examine continuity at which point? Pi by 4. You may also ask, can we discuss continuity at x equal to pi by 2? Yes, we can. But you will notice that here a domain is temporarily broken at pi by 4. Means what? To the left of pi by 4, different definition. To the right, different definition. So function could possibly discontinuous at pi by 4. That is why we are asked to discuss continuity at pi by 4. But they could have asked to discuss continuity at x equal to any real number. Why? Because sine and cosine ratios are defined for all real angles. Okay. Now for limit extends to pi by 4 minus means to the left of pi by 4 means less than pi by 4. So which function? Sin x. I hope you won't say minus pi by 4. It is not minus pi by 4 minus. Pi by 4 minus means to the left of pi by 4, that is for less than pi by 4. Function is sin x. What is sin pi by 4? 1 by root 2. Limit extends to pi by 4 plus to the right of pi by 4. For that it is cos x. What is cos pi by 4? 1 by root 2. Now f of x is sin x for not only x less than pi by 4 but equal to also. So f of pi by 4 is sin pi by 4, that is 1 by root 2. As these three values are equal, function is continuous at x equal to pi by 4. See, you may present this as left hand limit equal to right hand limit. So limit, just limit, don't say left right now. Say limit extends to pi by 4 f x exists. Its value is 1 by root 2. It is equal to f of pi by 4. So function is continuous at x equal to pi by 4. Now third one, f of x is x square minus 9 upon x minus 3 for x not equal to 3, obviously. And f of 3 is given to be 8. And we have to discuss continuity at which point? X equal to 3. Again, if continuity is to be discussed at x equal to 4, it is also possible. But clearly, function is continuous at x equal to 4. Why? Because it is defined at x equal to 4, right? Rational function is continuous if denominator is not 0. Simple. Now here, what is f of 3? It is given to be 8. Let us find value of the limit. What are the factors of x square minus 9? X minus 3, x plus 3. Cancel x minus 3 because x only tends to 3, not equal to 3. Take the limit. Value of the limit is 6. You have to say as limit x tends to 3, f of x not equal to f of 3. Function is discontinuous at x equal to 3. Second question, examine whether the function is continuous at the points indicated against them. This is actually similar. First one, f of x equal to x cube minus 2x plus 1 if x is less than or equal to 2, 3x minus 2 if x is greater than 2 at x equal to 2. See, many students say that, what is this? X less than, x greater than, again at x equal to 2. See, this is how function is defined, piecewise function, and we are asked to discuss continuity at one particular point of the domain, and that is 2. That's it. Now, f of x is x cube minus 2x plus 1 if x is less than or equal to 2. So, limit extends to 2 minus fx. What is the value of limit? Take limit in the first step, 5. F of x is 3x minus 2 if x is greater than 2. So what is that right hand limit? It comes out to be 4. Left hand limit is not the same as right hand limit. So limit does not exist. So clearly function is discontinuous at x equal to 2. See, there is no point in finding value of the function at that point, because left hand limit is not same as right hand limit, so limit doesn't exist. In the next lecture, we are going to call this discontinuity as irremovable discontinuity. Now, third cell, what is f of x? It is x upon tan 3x plus 2 for x less than 0 and is 7 by 3 for x greater than or equal to 0. And we have to discuss continuity at which point? At x equal to 0. So f of 0 is given to be 7 by 3, number 1. For right hand limit, we have to use 7 by 3 only because it is for greater than or equal to 0. What is left hand limit? For that which function? X upon tan 3x plus 2. Here I have omitted one step. Divide numerator and denominator by x. Actually, we should mention the reason also. X only tends to 0. X is not equal to 0 because we have divided numerator and denominator by x. Angle must be fully repeated. So though it is x, I have written 3x to make hisab barabar into 3. Limit of constant is constant. Again, we could have added one more step in the sense numerator, instead of writing 1, we can write limit extends to 0 of 1 and then in the next step 1. But here I have directly taken the limit. What about limit of denominator? It is 1, standard limit. Angle is in radian, angle tends to 0 and is fully repeated in the denominator. So this 1 by 3 outside the limit being constant. So 1 by 3 into 1 upon 1 plus 2. So 7 by 3. Now from 1, 2 and 3, limit extends to 0 minus fx equal to f of 0 equal to limit extends to 0 plus fx. You need not write equal to 7 by 3. It is sufficient to say that these three are equal. So function is continuous at x equal to 0. Now, actually third sum is based on step function, but before we discuss the solution, you should know about step function. Greatest integer not greater than x. Okay. Now, what is step value of 1.4? Logic is very simple. You have to consider nearest integer to the left. I repeat, nearest integer to the left. So step value of 1.4 is not 2. Why? Because greatest integer but not greater than 1.4. If you say 2 is greater than 1.4, right? You can say 0, but no, greatest integer. 1 is greater than 0, but is less than 1.4. So on the graph paper, this is say 1.4. I am not drawn graph to the scale, but nearest integer to the left. So 1. What is step value of minus 3.1? Don't say minus 3. Nearest integer to the left, that is minus 4. Now from the graph, if you use common sense, you can tell me that this step function is discontinuous at integral values, at integers. Why? Because there is jump, there is break. There is jump at integral points. And therefore, it is discontinuous. Is that clear? So this is about step function. Let us discuss sum number 3 now. Find all the points of discontinuities of f of x equal to step x on the interval minus 3 to 2. If asked in CET, you need not do this part. Basically, it is an open interval. So minus 3 and 2 do not belong to the interval. So which integers lie between minus 3 and 2? Minus 2, minus 1, 0, 1. That is the answer. So function is discontinuous at which points? 4 points. Minus 2, minus 1, 0, 1. But if asked in college exam, you have to write solution like this. So f of x is greatest integer not greater than x. X belongs to this open interval. So f of x is minus 3 for x belonging to this interval minus 3 minus 2. It is minus 2 for x belonging to this semi-open interval. See, if x is minus 2, greatest integer not greater than minus 2 is minus 2 only. Right? So minus 2 is included, but minus 1 is not. Again, f of x is minus 1 for this semi-open, minus 1, 0. F of x equal to 0 for this semi-open interval, and f of x is 1 for this semi-open interval. Now consider continuity at x equal to minus 2. Now you'll ask me, why not minus 3? Minus 3 doesn't belong to that interval, and therefore we do not consider that. What is limit extends to minus to minus? It is nothing but minus 3. See, minus to minus means you have to consider this. So it is minus 3. What is limit of minus 3? Minus 3 only. What is limit extends to minus 2 plus? Minus 2 plus means greater than minus 2. For that, it is minus 2. So what is limit of minus 2? Minus 2. Now left hand limit is minus 3. Right hand limit is minus 2. They are not equal. So limit does not exist. So function is discontinuous at minus 2. Similarly, you need not prove for remaining. Similarly, you can say that function is discontinuous at other integral values of x, minus 1, 0 and 1. And therefore, conclusion is function is discontinuous at minus 2, minus 1, 0 and 1. Fourth one is an interesting sum. Discuss the continuity of the function f of x equal to mod of 2x plus 3 at x equal to minus 3 by 2. Basically, modulus function is continuous. Mod x is continuous. Now it is mod of 2x plus 3 and we have to discuss continuity at minus 3 by 2. I hope you remember the definition of modulus function. See, f of x is 2x plus 3. When this part 2x plus 3 is non-negative. For example, mod 7 is 7. So mod x is x when x is greater than or equal to 0. Now instead of x, it is 2x plus 3. That is why I have written mod of 2x plus 3 is 2x plus 3 if this part is greater than or equal to 0. Rearrange the terms. That is x is greater than or equal to minus 3 by 2. Now mod x is minus x when x is less than 0. So mod of 2x plus 3 is minus in bracket 2x plus 3 if 2x plus 3 is less than 0. That is x is less than minus 3 by 2. Now, what is f of minus 3 by 2? Remember, we are asked to find or rather discuss continuity at minus 3 by 2 only. So f of minus 3 by 2, you have to select this function 0. Limit extends to minus 3 by 2. Minus means to the left of minus 3 by 2, that is less than. So it is minus of 2x plus 3. No problem. There is no plus 0 minus 0. So left hand limit comes out to be 0. Same is right hand limit. Limit extends to minus 3 by 2 plus. Limit extends to minus 3 by 2 plus means greater than minus 3 by 2. So for that, it is 2x plus 3. So 2 into minus 3 by 2 plus 3, that is 0. Actually, this is number 3 and this is number 2. Okay. So I can say from 1, 2 and 3, from 1, 2 and 3, limit extends to minus 3 by 2 minus fx equal to f of minus 3 by 2 equal to limit extends to minus 3 by 2 plus fx. F is continuous. The presentation is important. Is continuous at x equal to minus 3 by 2. I hope you have written in the top margin for the previous sum that step function is discontinuous at integral values. If you haven't written, please write in the top margin for the previous sum. So this is about sum number 4. That's it for today.